Okay, thank you, Britta. Can everyone see my monitor? Look okay? Yes, okay. Well, thanks, Britta. That was great. It's amazing commission, and thanks for supporting all the work that we've been doing. And also welcome everyone, and thanks for being here. So one of the goals of the workshop series is to give an update on the progress of the Tephra working group. So I plan to give some background on how we got here, and then what we're doing, and finally where we plan to go next. So this is the work of an international working group that includes participation from more than 100 geoscientists. So certainly not just me here, just reporting out. So first, let's talk about the motivation of the Tephra working group. So as you all know, Tephra studies are incredibly just interdisciplinary and widespread across the globe. Tephra deposits form a common thread that connect multidisciplinary researchers who share overlapping data needs. So I love this graphic. It's just a huge web of interconnected disciplines that all focus on Tephra. So Tephra studies, however, are challenged by the lack of standardization that prevents comparison of data sets among various regions and across disciplines. And also data are stored in disconnected databases and offline files, limiting their access. So in recognition of some of these challenges, a series of meetings and workshops in volcanology, tephrochronology, quaternary sciences have been held over the past decade or so to help improve the study of Tephra. We've highlighted a few of them here, and some of them were already mentioned by Britta. So in 2006, IOFSE held a workshop on best practices in maximum class measurements for use in modeling applications in volcanology. The International Focus Group on Tephrochronology and Volcanism, or INTAV, that Britta mentioned, hosts an interdisciplinary or an interlaboratory round robin focused on best practices in geochemical analyses, where 21 labs and 9 nations participated. In 2011, the group Tephra and Quaternary Science was initiated, and they held a workshop to promote cross-group collaboration for optimizing and advancing tephrochronology, following on the heels and the momentum of the 2010 Eyjafjallajökull eruption in Iceland. And in 2018, the INTAV also hosted a workshop focused on extending Tephra as a global geoscience research tool, stratigraphically, spatially, analytically, and temporally. And this resulted in the special issue that Britta just mentioned in the Journal of Quaternary Science, titled Tephrochronology as a Global Scientific Tool. So the focus of this workshop series, Tephra Fusion 2022, is an update of the progress made following an additional set of workshops and meetings held between 2014 and 2019 that focused on an interdisciplinary viewpoint. So this includes the entire research process, from sample collection, processing, analysis, and reporting. So here are some photos from the various workshops, and they include folks from across the globe in various disciplines, and also include many of you that are participating today. So thank you. So those multidisciplinary workshops build upon all of those past efforts and drew consensus from more than 100 members of the global Tephra community on the needs to, one, identify, develop, and share best practices in Tephra data collection, analysis, and reporting across different scientific disciplines. And two, to establish common accessible mechanisms for Tephra data archiving and retrieval. However, all agreed that standardization was the necessary precursor to widespread database development and data sharing. So in recognition of this, we focused the last 8 years on the development of this framework of best practices as the first steps towards standardization of the protocols for collection and analysis and reporting of Tephra data. And we view these protocols as a way of finally linking that diverse research community and scientists. So the best practice recommendation framework is a catalog of data developed to aid researchers in knowing what are the best data or most important data for generating the highest quality data sets. Their guidelines formatted as tables or spreadsheets that contain fairly comprehensive list of information that are recorded in all phases of the Tephra analysis. And so We're talking about collection, sample processing, and then all of the analyses, geochemical, physical, microanalysis, as well as correlation. So here's a screenshot of the introduction tab of the collection workbook. So one of the workbooks, one of the 6 workbooks. Each of the theme workbooks has an introduction tab, just like this one, and it outlines what is in each individual tab within that workbook. So notice that there are many tabs in each of the spreadsheets, and they're mimicking a typical workflow for that. So in this case, for a Tephra collection. Here is another screenshot of the sample tab within that same Tephra Collection workbook, and it's showing just its format. So here is the category, and that shows you sort of what is the data that we're asking for, or the metadata, the name of that. And then over here is an explanation or a definition or an example of that data, and then any key references as appropriate. I also noticed that we've identified in either or bold and asterisks the most important minimum data to record. So if you do nothing else, we hope that you record those data. But of course, we encourage you to review and consider documenting other details, not just the minimum baseline, because this may benefit the broader community and make your data set more valuable to everyone. All right, so here's a screenshot of the open source citation in Zenodo, where you can find the latest version, well, actually all versions of the best practice recommendation spreadsheets. They sit here for you to visit. They're for public consumption and for your comment. We always appreciate and need feedback on these. And we have a supporting manuscript that's currently in review with Nature Scientific Data. Okay, so because there's been some confusion about how to use the best practice framework, we wanted to emphasize that although the spreadsheets are in fact fairly comprehensive, we know that no one person or no single study will ever aim to record all of the recommended data. So it's important that you make the spreadsheets work for you. So here are some ways that we envision implementing the best practice framework. They could be used to build data collection templates or checklists, develop workflows, develop databases and data repositories, to train students, build digital tools, build data reporting methods and templates. For example, these workbooks are not intended as data sheets to record information, so they're not templates themselves. They're also not a set of database tables to build your database. But rather, we'd like you to try to see them as a catalog of key data identified by the global Tephra community as most important in generating high quality data sets and ultimately maximizing data sharing and collaboration. They're intended to be comprehensive, of course, but they're also intended to be flexible and used as a guide rather than to be prescriptive. All right, so big picture, the best practice standardized framework will foster interdisciplinary communication. They'll improve interoperability of regional and global data sets. So here we've listed a short list of anticipated specific goals of the best practice framework. We think that they'll ensure consistency in data acquisition and reporting among Tephra scientists, regardless of their research focus. They'll provide basic comprehensible metadata requirements, especially for those who collect data peripheral to as a peripheral part of their research. They'll enable the community to create compatible data sets that can be built upon and readily reused. They'll help train students to identify and collect relevant data. You can use them to develop templates for publication of supplementary data and methods documentation. They can be used to inform digital tool and data repository development. They could help journal editors and reviewers to know which essential information should be included in published works, and aid in data management plans required by most funding agencies. So here are some examples of some recent implementations of the best practice framework to give you an idea of how they could be used. We worked with the developers at StravaSpot, which is a field application, to develop a set of Tephra-specific templates to aid researchers in data collection. So StravaSpot Tephra will be the focus of the February 18th workshop in this series, and it'll be led by its developers. We've also worked with NSF's EarthChem data repository on a new Tephra community portal that will allow users to follow simple workflows and register samples with the System for Earth Sample Registration, or CSAR, as well as to submit microanalytical data and analytical methods to EarthChem. This is the focus of the February 25th workshop, and it will also be led by its developers. So we hope that you will attend both of these workshop sessions over the next couple of weeks. Another example is at the Alaska Volcano Observatory, or AVO, where I'm employed and also run the Alaska Tephra Lab. We've recently adapted our laboratory data entry spreadsheets, a snippet of which you can see here, using the best practices, and also have adapted them or formatted them or mapped them so that they can be rapidly uploaded to AVO's database, which is called GeoDiva. And this significantly improves our workflow and documentation for both prehistoric eruption and eruption response studies. We've also developed data queries from GeoDiva that create tables suitable for publishing, and this greatly facilitates faster publication of our data sets. And there are plans underway to create detailed and flexible data dictionaries, streamlining future publications of data. So these examples of adoption of the best practice framework to develop templates and upload them to repositories improves fundamental Tephra science practices. It supports data management for researchers. It allows faster access to key research for secondary users, and it meets the FAIR data principles of findability, accessibility, interoperability, and reusability that Kirsten Leonard will be talking about in a little bit here. So we found this quote given by George Strawn during a plenary talk at the Virtual Science DataCon 2021 regarding open data. And by the way, George is the director of the Board of Research Data and Information at the National Academy of Sciences, Engineering, and Medicine, and I'll read it here. Oops, sorry. So he says, 17th century open science meant publishing articles describing science results. 21st century open science means sharing all science results, so articles, data, software, workflows, etc. But sharing all science results includes planning the sharing before the experiment, not at the end of it. And these shared outputs should be machine readable and, where possible, machine actionable. The new open science is the child of the internet. So I thought this was great, and hopefully it encourages us all to move out of the 17th century science practices and move towards this goal described by George. Okay, so where are we going? All right, the focus of the final workshop in the series on March 3rd is next steps. And so it's really important to attend this session. So we hope that everyone will be there for us. So at very minimum, we will include discussion of building open Tephra data systems and tools to facilitate efficient data integration, access, and use. So of course, we wanted to first focus on the standardization point, and now we need to move forward into this first bullet here. And we also need to think about ways to encourage the adoption of the best practice framework. We know that everyone is super duper busy, and we really hope that you can join us on May 3rd to help develop the future roadmap. We'll be gathering thoughts and ideas throughout the course of the next 3 weeks during this workshop series to help inform that session. And so please, please don't hesitate to send us your thoughts and your ideas so that we can include them in the final session. And with that, I will end, and thank you.